humanity is facing many challenges. If current unsustainable practices persist, climate change will intensify, leading to devastating consequences such as habitat destruction, biodiversity loss, and widespread displacement of populations. Additionally, humanity's venture towards becoming an interplanetary civilization, with initiatives aimed at settling on the Moon and Mars, underscores the need for innovative habitats tailored to extreme conditions. In the years ahead, there will be a growing demand for habitation solutions that repurpose local resources, including waste, for alternative uses, reflecting the imperative for sustainability in both terrestrial and extraterrestrial contexts. Bioregenerative life support systems are pivotal here. They mimic natural ecosystems by fostering symbiotic relationships among plants, animals, and microorganisms, recycling waste, purifying water, and generating food and oxygen. These systems aim to establish self-sustaining environments for life in harsh conditions on Earth and in space. At the moment, the majority of these systems are created using materials brought in from external sources. If the settlement were to expand, it would continue to rely heavily on existing infrastructure and imported materials, which might not always be feasible, especially in emergency situations. In response to this challenge, Vershinina, an architect and PhD candidate at KU Leuven, partnered with Wieger Wamelink, an exobiologist, ecologist at Wageningen University, and the founder of BASE. Together, they developed the ExoGarden project. It is a prototype for a regenerative habitat that uses advanced 3D printing and space food production technologies to rapidly produce shelter and food in extreme environments. ExoGarden resembles a series of interconnected arches forming a vertical garden system. The structure consists of modular elements 3D printed from local materials like clay or regolith. These hollow modules can hold earth soil or Martian regolith for cultivating edible plants. The modules have a textured bioreceptive surface that promotes the growth of cryptogamic organisms that absorb carbon dioxide and pollutants, bioremediating the environment and encouraging the growth of plants. Organic waste is composted within the perforated core of the structure. The core also hosts worms, which aerate the soil, facilitate nutrient cycling, improve soil texture, and promote microbial activity, all crucial for plant growth. As part of the educational aspect of the project, Vershinina and Wieger Wamelink created a comic book to explain the project through the stories of 3 characters, Mia, Lucia, and Stella. These characters navigate the consequences of climate change in extreme cold, extreme heat, and in space. They introduce exogardens as a new infrastructure and way of life that harmonizes with nature and utilizes local materials. By adopting the ExoGarden design approach, our buildings have the potential to become environmental assets, actively bioremediating and enhancing biodiversity. The incorporation of bioregenerative systems would lead to a significant reduction in waste, with much of it being reintegrated into the building's ecological cycle. Eventually, parts of these structures could naturally decompose, enriching the surrounding environment. This concept could extend to extraterrestrial habitats, offering sustainable solutions for inhabiting other planets. These life-affirming and resilient strategies not only empower communities in challenging environments, but also redefine the standards of habitation for the future.